Bismillahirrahmanirrahim. Assalamu alaikum and welcome to my YouTube channel Maths with Samreen. In this video, we will discuss the graphical method to solve a linear programming problem. So, what is a graphical method? It is a technique used to solve a linear programming problem with two variables. Following these steps, we can find the optimal solution of our linear programming problem. Step number 1, plotting the constraints. Step number 2, identifying the feasible region. And step number 3, plotting the objective function, and at the end finding the optimal solution. Let's take an example to understand it further. So here is an example. In order to solve a linear programming problem, it is very important to first understand the problem, that what is given and what is required. A company manufactures two products A and B. Both products are processed on two machines M1 and M2. This is the data given. M1, which is the machine 1, it takes 6 hours to produce 1 unit of product A. And similarly, machine 2 takes 2 hours to produce a single unit of product A. And for product B, machine 1 takes 4 hours per unit and machine 2 takes 4 hours per unit. The availability of the machines are given. Availability of machine 1 is 7200 hours per unit and machine 2 is 4000 hours per unit. That is, we cannot use these machines more than this limit. Also, it is given that the profit per unit of A is 100 rupees and for B is 80 rupees. We have to find the monthly production of A and B to maximize the profit. That how many products of A and B should be manufactured monthly so that our profit can be maximized. So first we will write the decision variables. X1, as we have to find the number of products A and B to be produced. So we let X1 be the number of product A to be produced. And X2 be the number of product B to be produced. And then we write the objective function. As it was given that we have to find the maximum profit. So we write max and named our objective function as Z. Okay. So profits were given of product A and product B, which is 100 for product A. So we write X1 here. And we add, because we have to find profit of the both products. So we use a plus sign here and write the profit of product B with the variable X2. So this will be our objective function. Now we have to write the subject to constraints by using the following data. As it is given the availability of the machines 1 and machine 2. So we write the constraints as 6x1 plus 4x2 and the availability is 7200 hours. We will use a less than equals to sign because we can use the machine less than that, not more than that. So to write the other equation, similarly we use 2x1 as machine 2 takes 2 hours per unit for product A and 4 hours per unit for product B. And its availability is 4000. And third constraint that we must have to write is that x1 and x2 is greater than equals to 0. It is always greater than equals to 0. Let's give numbering to these equations as 1 and 2. As in this method, we have to plot the graph to find the feasible region first and then find the optimal solution. So we write the equations of constraints with the sign of equality and then solve them to find the points. First, solve equation number 1 by putting x1 equals to 0. 6 into 0 plus 4x2 equals to 7200 and it will give x2 is equals to 7200 by 4 which will give 1800. So the point will be as we write x1 and x2 as the point here, x1 is 0 and x2 is 1800. Similarly, we put x2 equals to 0 in the same equation. 6x1 plus 4 into 0 equals 7200. x1 will be 7200 by 6, which is 1200. So the point will be x1 is 1200 and x2 is 0. And by solving the second equation, put x1 is equals to 0, 2 into 0 plus 4x2 is equals to 4000, x2 will be 1000. And the point will be 0 and 1000 because x1 is 0 and x2 is 1000. Similarly, put x2 is equals to 0 in equation number 2, it will give 2x1 plus 4 into 0 equals to 4000. So x1 will be 2000. Now use these points to plot the graph. Now let's draw these points. We take x1 on x-axis and x2 on the y-axis. Consider this point for the constraint 1 where x1 is 0 and x2 is 1800. So it will lie here where x1 is 0 and x2 is 1800. And for the point number 2 for constraint 1, x1 is 1200 and x2 is 0. x1 1200 lies here and x2 is 0. Join the following points. This is the line for constraint number 1. And other for the constraint number 2, x1 0 and x2 1000. Here, x1 0 and x2 is 1000. And similarly for the other point of constraint 2, it is x1 2000 and x2 0. x1 2000 here and x2 is 0. So the point is 2000, 0. Join these points. This is the line for constraint 2. Now we have to shade this graph. We use the equation number 1 and equation number 2 to shade this. In equation number 1, a less than equals to sign is given. So, which implies that we shade the constraint line inwards. For constraint number 1, the shading region will be like this. This is the line of constraint 1 and we have to shade it inwards. So we shade it like this. And for constraint number 2, it is again less than equals to sign. We again shade it inwards as well. This is the line of constraint number 2. So we shade it like this. Now you see there is a common region for both of the constraints C1 and C2, which is this region. This is our feasible region. We have to find these points. So we name it as O, A, B, C. Already know the value of this point, which is 0, 0. And also this point C equals to 1200, 0. And A is 0, 1000. We just left with point B. We have to find point B, x1 and x2. To find the point B, we will solve these equations simultaneously to find x1 and x2. By solving these equations simultaneously, we found that our point B is 800 and 600. That is, x1 here is 800 and x2 is 600. Now, we got all the points O, A, B, C. We put these points one by one in our objective function to find the optimal solution. The objective function was maximum of z is equals to 100 x1 plus x2 and the points were O, A, B, C. By putting them one by one, here it is x1 and this is x2. So putting x1 and x2 equals to 0, the result is 0. And here x1 is 0, x2 is 1000, 100 into 0 plus 80 into 1000 gives 80,000. And the point B, x1 is 800 and x2 is 600. Putting it into the objective function, we get 100 into 800 plus 80 into 600, which will give 1,28,000. And similarly for point C, 1200, 0, 100 into 1200, that is 100 into x1, and 80 into x2, it is 1,20,000. Now we have to find the optimal solution, and we were calculating the profit, so we always choose the maximum value which is giving us the maximum profit. So you can see the maximum value here is 1,28,000, which is given on the point 800 and 600. So our problem was to find the maximum profit and the number of products of A and B to be produced in order to maximize the profit. Here the maximum profit is 1,28,000, which is at the point B, x1, x2, where x1 is 800 and x2 is 600, which means that number of products of A to be produced in order to maximize the profit is 800 and that of B is 600. If we produce 800 products A and 600 products B monthly, then our profit will be maximized. So this was our today's lecture. I hope that you understand it. If you have any query, you can ask me in the comment section. We'll meet you in the next video. Till then, Allah Hafiz.